Welcome back. Now let's talk about tiling or flooring works that we have it. Now it's very easy. Within the sections we will be having some detailings here. By the way, I think we have this one in an English version that you're supposed to know the layers that you have it here. Now I already did this one. You have the English version of this. So you know, for example, there is maybe a tile, you have it, maybe above it you have a mortar, maybe you have a glue, whatever you have, those are all of them, they have the same way. So for the flooring, whatever you have it, you can calculate all of them together. That way, even for the first floor, if you have it, second floor. Now how do we calculate these things? We calculate them based on the area. Now the area already will be given to us here. For example, take any room, the area is given to you, 23.1. I'll just give you some detailing. That's easy, that's why I'm gonna go into detail. Just give you some. Now when you're calculating, for example, tiling anything, you will take the area. You can take inside area, but you have to take something out of it. Why? Because there's a column at this corner which you don't have tile there. So this you'll take if the area is not given to you. If you use AutoCAD, you can calculate the area of the place that you want it. But if you do it with the table, you have to take care of these small corners there. As minus, you can write it. This is one. What else you have to add? This is extra you're taking out of it. If it's tiling, you will add under the wall. But remember, under the wall, you'll add it only for this one here. You'll not add it for the other side as well. Because under the wall, you have tiling going on, yes? So you have to cover that one as well there. Sometimes you have let's say in the bath, sometimes you have inside, for example, this is the bath, you have it. Sometimes they do even the wall. They do floor, you have the flooring here. So you have the flooring here. So you have to take inside. So it's going to be somewhere from here. Then if I will take care of this extra, take this extra column. Then maybe even I have what? Maybe I have wall. It's still possible. If, for example, here and here, most probably it is you have a tile there because there is a water. So the height of this one. Sometimes they do the whole wall. Some places they will do even the fourth side of the, for example, the bathroom. All of it will be tiled. So it's possible. You have to know it. You can take care of this one. You will not calculate in that time the cement plastering here. The cement plastering that you have it there, it will be tiling in that case. Now if this area is given to us, I can use this area exactly to calculate the tiling here. So for example, flooring, I can write tile, whatever it's under the layer I have it, I can just simply write this one 5 meters square, and that's it. Or if the area is not there, you'll calculate the area and you'll take care of this one out of it. So that's why most of the plans now, they have the area inside it, so it can be. But you have to be careful. This area is exactly taking care of this small corner. You have to check it to see if it is, directly use it. If not, by yourself, take care of these small corners there. Now let's say, I don't know, I'll check it here. Maybe this is not exactly the area. Let me just take the tile, this part here. Let's say I'm taking inside, and I'll take care of these small two corners for the column. Let's say. So we have 4.05, 5.7. So I'm writing it down. I believe that this column is a bit different because I think the civil engineer designed this one to be something like this. Design it to be like this. So I'm gonna write this one. Let's say the flooring here, we have it. This is the same thing. We'll write the names in order to know what we're doing here. Now we only have one. Now I'm doing it manually, so it will be 5.7. We already calculated this one before, 4.05. Then the height, I don't have it here, I'll just write 1 here. Now this is the whole. I'll take some minus out of them. The minus will be the corner for the columns. So if I zoom in to see the corner for the column here, what we have it. when I took the area, it's kind of was like this, so I have to take care of this extra. Now this is 10, so this side will be 15, so I have 15 by, this is 20, and the column by itself, it's 65, so this will be 40 here. So I have to take out this area, which is, I wrote it minus here, minus 40.4 by 0.15. This is one of them. I can repeat for the other column we have it there, which is gonna be, in the other corner. I'm taking care of those two corners because there is no tile there. This column, it's designed differently by the civil engineer. I think it designed it to be 120. Yeah, they designed it to be 120. The civil engineer designed this one to be 120. Yes. So the same idea. We're taking care of this area, because when we took the area, it was something like this. It was going like this. So we'll take care of this extra area here. Well, we can calculate it. If this is this wall here, it's 10, so the remaining will be 110. So we have another minus 1, another minus 1. We have 110, where the thickness is, again, this is 25. Take 10, 15 will remain there. So those are, and this I'll put 1 here, for the calculation. Those are the minus. So when I'm calculating this, those will be minus coming there. Well, what else we have to add extra? We said that under the door, I will add it. So under the door basically will be this. With the door, it's 90 centimeter. So this is 90. The thickness will be the thickness of the wall, which is 10. So it's kind of, let me just clear this side here. This is what we're going to add here. A small under the wall. Under the wall, we're adding it. We know this is 90 centimeter, and the thickness is 10 centimeter. We're adding this one as well as extra, so there will be 1. We can write it here under the door. This is what column. It's better to write them. For example, if this is column, whatever the column name there, you write it, for example, 120/65 column. And this is the 65/25, 25/65 or 60 column. I don't know, the 65, I'm not wrong. 60 column. You can write it like this. I think it was, I don't know, 25, 65 or 60. If it's 60, then this one will be 35. If it's 65, maybe 40. Whatever. This is the wall under the door. You can write it under the door, which will be 0.1, which is 10 centimeter, and when you have it there. In this manner, you calculate all the tiles and the total of it. For example, it's only for one room, remember. You can do it for the rest of the room, and you have, for example, here 23 meter square. Now you realize that it's kind of a bit small, like close to the, this is 23.1, because I believe that it's only 23.1 only the room, so without taking care of these things. So it's, if you're not sure this is exactly, look, it comes 23 meter. It's a bit difference because of those small corners we have there. So sometimes the area given it for the based on just 405 times 5.7. It's only the area of the room. So in order to calculate accurately, I recommend you to do this manner to make sure you will take care of these corners, the columns, and if you have under the room, to take care of it. So remember, if the door is between two of them, you'll just take care of it once. You're not going to add it twice. This is something you have to know. What else you have to know about this works here? Well, the other things, it's mainly working with the areas here. They will not be hard, because this flooring is the easiest thing that you have it there. Well, the hardest part for this will be roofing, especially when you have this kind of roof, which is sloped one. I will just explain for you, but I'm not gonna go into detail of them. I mean, too much detail, but it's a bit confusing due to the geometry. So I'm explaining how to calculate, for example, how to calculate area of this one. Now some they say that we can use AutoCAD, but I have to tell you that you cannot use AutoCAD to calculate this area because it is sloped. It is not horizontal, it's not vertical. This one, this is sloped, so you have to find this slope. Kind of, if I do it in a kind of 3D, it look like something like this. So you have come out like this. It's kind of like this you have it. So it is in a 3D looking like this. So when you're calculating this area here, it's not something easy. First thing, you have to calculate this slope, I mean the length of this slope. If you calculate the length of this slope, then you can calculate the areas. So you need to calculate this. In order to calculate this slope, you need this height, and in the base here, you need the base. Now the height will be found from the elevations, and the base of it will be found from the roof plan. Then using the Pythagorean theorem, which is a square plus b square is equal to c square, you will find the slope. This is c here, and then you're going to use this one in order to calculate this area, which will be triangle. You will get this one as well from the plan. You can get this distance from the plan, this distance from the plan. You can get those distance from the plan. It's easy. Those will be, or you can take all of it. If those two rectangles are symmetry, I can bring this one here and calculate it as one rectangle. It can be, but not always you can do this simplification. You have to be careful while dealing with this roof. Well, I'm just going to show it to you to see how we can gather this information in order for you if you want to do it later. Well, let's say I'm taking this. This is first, I have to know where is it. So this part here, I have to know where is exactly in the roof, which is gonna come, will be this area here. It will be, yeah, so all the dimension I'm taking it will be somewhere related to this part here. This is the area I'm going to calculate. This is the area. So we're looking for this distance, how much it is. Now this is kind of in the middle of the so we know this, how much it is. It's given to us exactly here. So we half of it, we'll take it, we get the base of it. Look, this is the top view, I'm getting the base. From the top view I got the base. So let's see how much the base will be. It is 940 divided by 2, that's gonna be 4.7. So the base is 4.7. The base is 4.7. This is one. Now I need to get the height. The height of it, I'm gonna go for the elevation, which we know from here. This will be the height. It will not be the length of it, will be the height, which is 6.5, and I have 8 here. So 8 minus 6.5 will be 1.5, which is the height of it. Now I can draw this. And find the length of this roof here, because 1.5 for the height, 4.7 for the base. Then I can call this one C, which we can find is 1.5 square plus 4.7 square equal to C square. So if I find C here, Then I can come here. Now assume that this is C here, this is C. Then I can divide this one into areas, like into areas. If this is the same as this one, so I can basically, we said I can bring this one to this part here. Let me calculate C here. This is for roof. You can call them, naming them, because you have to name. For example, this is 1, this is 2. You call them like this. This is 3, maybe somewhere else 4. In order to know which area you're calculating, you number them. Numbering, it's something good for later control. So let's say I'm just doing this part over here. Let's say I'm calculating C somewhere here, which just have C. We said that 1.5 square, 4.7 square. So the C will be 4.93. The C, which is here, 4.93. You cannot feel it here. You cannot feel it here. It's where do you feel it? From the roof plan. From here you can feel that this is the 4.93. Now when you're calculating the area, imagine it like this. This is what you're calculating it. From here it will be easier to imagine it. 4.93 times this one. Yes. So if I do a bit for whole area, this way we can see all of it. So you're calculating the area in this manner. We say we can divide it into two rectangles. We have the height of them, two triangles, sorry, and one rectangle. Or if those two triangles are symmetry, I can just bring this one here, and that will be easier to bring it here and just calculate it as one rectangle. That will be easier in that case. We'll calculate it as one rectangle, area as one rectangle. Well, the dimension here, some of them are missing, but total is given to be 11.2, which you can divide it into 2. Will give you up to here, but you need this distance here, so you have to unfortunately I was trying to use it, but it's not up to scale, so I couldn't calculate this how much it is. So kind of it will be 1 meter here, 1 meter. Now you can calculate, if this is 1 meter, you can calculate the base of this, the base of this one, and you can calculate the area, 3 of them, and add them together here. Or I can make it easier. For example, if this is 11.2, I'll take 1 meter out of it, which will be 10.2, divided by 2, in order for each triangle with 5.1. So each triangle, the base is 5.1. Now if I take this rectangle, 5.1 plus 1 will be 6.1. I'm taking what? I'm taking it as one rectangle. Why? Because we said if those two are the same, so I can assume I can use this rectangle. It's easy for calculation. We'll write it here. This is only one, one of them for the roof, not everything. The length of it, 6.1, 5.1 for the triangle, 1 meter here, 5.1, and then the width of it will be 4.93, the C that we calculated, because we said that with this distance is 4.93. So I can write this one, which is 4.933, and this is one here, and I got, for example, this is only one area. Then you will go for the rest of them. Each of them, they have different, but it's pure geometry. You will be able to calculate it, but you have to divide it into different areas in order to calculate this procedure. So it's one of the hardest geometrical calculation for the roof, especially when you have this complex sloped roof. I believe that's enough for bill of quantity, well, there are some small detailing. Now you can calculate, the door, you have to provide doors, windows as number, but you will collect them together. For example, you go through the buildings, you see how many doors you have at the same size. For example, this is K2, this is K2. Do you have another place K1? So you will calculate all of them. This is K2. You will write K2 390 by this one. You just write it like this as number. You will write it down. Not their area does not matter because it's already here. So it's number. For example, K1, which is 90 by, for example, K2, which is 90 by 210. For example, we have 10 of them. The windows the same way. For example, how many windows 160 have it? You just write them like this, just counting them, no problem. You write, for example, you write it like this. For the door, for example, you write D2 like this, 90 by 210 centimeter. Write it like this. For example, we have 6 of them. I don't know, but let's say 6 of them. D, for example, whatever, door, 2 door, 1 window, 2, you name them and you size them beside it and you see how many you have it there. That's the way that you do for the door and window. You're not going to take care of this, what they call the inside stuff. You just, for the bill of quantity, that's what we have to do. Well, I didn't go for detailing of the slab for the stair as well. Detailing for the stair, you have the thread, you have the riser. I will leave this one for later. When you graduate or you see stair design, it will be easy to understand where do you have the tiling, the edge of it. Because when you go somewhere where there is a stair, please check the stair, the face of it, to see where the tiling will be, in order to calculate the tiling in case for the later. For this purpose of this course, I'm not including that one inside it. I think that will be enough here for the bill of quantity. Thanks for listening.